Hello kids, welcome back to Pre-Algebra. We are in section 1.2. We're working on properties of addition today. I'm using Bob Jones University Press, Pre-Algebra for Christian Schools. You can use any pre-algebra book, but what we're talking about is going to be the same. Lame joke for the day. Everybody knows why the chicken crossed the road, right? To get to the other side. Well, why did the dog cross the road? Well, to get to his barking lot, of course. And why did the chicken, when she started to cross the road, why did she stop in the middle of the road? Well, she wanted to lay it on the line. So, with that said, what are properties of addition? Well, a property in math, it's a mathematical pattern that you know is always going to be true. For example, if I ask you what 2 plus 3 is, you're going to tell me that that's 5. If I ask you what's 3 plus 2, you're going to tell me that that is also 5. If I say, what is 4 plus 17? Hopefully you're going to tell me that's 21. And you're also going to tell me that 17 plus 4 is 21. Well, what's going to happen now? 1 plus 2 is what? It's 3. 2 plus 1 is also 3. Are you seeing a pattern here? It doesn't matter what order we add numbers in. Two numbers, you add them. 2 plus 3, switch it around, 3 plus 2, you get the same result. It doesn't matter what order you add two numbers in. So this is a property of addition that's always going to be true, and what that tells us is that the order in which you add numbers together doesn't have any impact on that value. And we have a fancy long word that we use to describe this, and hopefully you've already heard about it. If you haven't, here's some more vocabulary for you. This is what we call the commutative. Commutative property of addition. It's the commutative property, and this tells us that order doesn't matter. Now, have you heard of commuter trains, or maybe mom and dad commute back and forth to work? Well, what's a commuter? Well, a commuter is someone who starts here at point A in the morning. Theoretically, it's maybe their house. And for those of you who haven't seen me before, you now see the sum total of my artistic ability. You see why I teach math and not art, because I'm not sure that I would even be able to pass kindergarten art or even remedial kindergarten art. But a commuter goes out in the morning and maybe drives his car or his short bed pickup truck and goes into the big city, or maybe not the big city, someplace, drives there to work. And then what do you do at the end of the day? Well, you turn right back. You're just going back and forth. They're commuting, so your commutative property of addition. I wasn't planning to do that, that was just free. The commutative property of addition tells us that order doesn't matter. When you commute, you go the same distance whether you're going, as long as you take the same path. When you drive from home to work, it's 15 miles. When you drive from work back home, it's 15 miles. You have the same value. That's what the commutative property of addition tells us. That no matter, that it tells us that order doesn't matter, and they have a particular way of describing this, and it talks about whole numbers. Do you remember what whole numbers are? Well, whole numbers are your counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it also includes 0. So when you have whole numbers, which would be 0, 1, 2, 3, 4, and the pattern continues forever. When you have whole numbers, you're going to have something that looks like this. This is the math sentence. for all whole numbers A and B, A and B, A plus B is equivalent or has the same value as B plus A. This is the algebra vocabulary that says that the commutative property of addition tells us that for all whole numbers A and B, A plus B is equal to B plus A. So that means whatever value you stick in here, as long as it's a whole number, 0, 1, 2, 3, 99,743, you add those together, it doesn't matter which number comes first. So the commutative property of addition tells us that order doesn't matter. Let me go ahead and write this up here. So there we have an example of our first property of addition that we're talking about today, which is the commutative property. The next one that we want to talk about is the associative property of addition. Now let's say that you're going out with some friends after church and you're going to go to get a burger, or maybe you're going to go play volleyball, I don't know. I'm not sure why you play volleyball in August in Texas, but you're going to go hang out, you're going to do something. And you can associate with, you've got like a bunch of different people in your group, but you can associate with all of them. But the whole group still goes together. Maybe when you start, you're hanging out with Micah and Bill and Charlie. And then halfway there you move and you're hanging out with Sally and, obviously I can't pull names up out of the top of my head, Sally and Karen, and then you get there and you're hanging with Carlton and Sue. But all of you are still going together. So the way that you grouped, that you associated together, the way that you were grouped together as you were moving didn't make any difference. So we now have the associative property of addition. And what this tells us, and I always have a hard time spelling this for some silly reason. Remember I said vocabulary? It's also spelling. Associative. It just never looks right to me. Associative property of addition. This tells us that the way that you group things together doesn't change the value of your expression. For example, if we have 4 plus 3 plus 2, we're going to see that that is the same as 4 plus 3 plus 2. Is this true? This says the quantity 4 plus 3 plus 2 is equal to 4 plus the quantity 3 plus 2. I'm going to put this little question mark in front of it. Now, this says the quantity 4 plus 3 plus 2 is equal to 4 plus the quantity 3 plus 2. Remember, with our order of operations, we're going to do stuff inside the parentheses first. 4 plus 3 is 7, plus 2. Is that equal to 4 plus, what's inside our parentheses over here? 3 plus 2 is 5. Well, yeah. 9 is equal to 9. It doesn't matter which pairs of number you group together. When you're adding, you're going to end up with the same answer. So this tells us that grouping doesn't matter. the commutative property says order doesn't matter. 2 plus 3, reverse it. 3 plus 2, they're the same thing. Associative property, grouping, which pairs of numbers you group together first, that doesn't matter. Now they also have an algebra speak for this. It's going to say for all whole numbers a, b, and c, a plus quantity b plus c is the same as the quantity a plus b plus c. And this is also commutative because I have this equal sign. What you have when you've got an equal sign, it's like a balanced seesaw. If you've got somebody over here on this side that weighs 80 pounds and somebody over here that weighs 80 pounds, it's balanced. It doesn't matter which way. It's still in balance. So this could also be written quantity a plus b plus c is equal to a plus the quantity b plus c. And what I've been writing here when I say use words to describe the associative property, I use an algebraic expression. This is what we're talking about here. Okay, but still, all we have that we're doing today so far is just vocabulary. Commutative property of addition, associative property of addition. What are properties? Properties are things that are always true. And as believers in God, as people who follow Jesus Christ, we see properties all through God's Word. God, the verse which I can't call reference to right now, it says Jesus Christ is the same yesterday and today and forever. That's a property. It's a consistency. He doesn't change. So the properties that are available in the world of math that God created, they don't change either. They have that same consistency. Commutative property of addition is always true. The associative property of addition is always true. And the last property that we want to talk about today, the third one, is the identity property of addition. Now let's think. If I have a certain number of cookies, and I want to add identity property of addition, and I want to add a number to that, so that has the same number at the end. I start with 12 cookies, I start with a dozen cookies, and I want to add something to it so that I still have 12 cookies at the end. What I'm going to add? Well, you're not going to add anything. Okay, if you've got 12 and you want to end up with 12, you don't add anything. How do we say that in arithmetic? Well, we add 0. 12 plus 0 is 12. 0 is what they call the identity element. That's not an O, that's a 0. Is the identity element. That means if you add 0 to any number, you're going to get the identical number. 0 is the identity element. So the identity property of addition would say for all real numbers, for any whole number, A plus 0 is always going to be equal to A. It doesn't matter if A is 1 or 1,000 or 1,000,000 or 29,757,000. If you add 0 to it, there's not going to be any change in that value. Now, why are we saying this now? Because it's real obvious if you don't add 0. I mean, if you don't add anything, it doesn't change. But what happens is we're going to use this identity property way down the road to let us do some really cool things. We'll just have, like right here, 0 just looks like 0. But we'll find out that we can do all sorts of manipulations of something that represents 0 that lets us solve problems down the road. So this is like just the very basic foundation of what we're doing. Now, that's all we have for the teaching. Let's go ahead and look at a couple of these problems so you can see what they're really asking you for. Because it's really applied English, I guess. It's just using vocabulary. Like for example, if we have number 7, and this is on page 7. If we have quantity 2 plus 9 plus 4 is equal to 2 plus the quantity 9, and I'm really getting pretty messy here. Let me make this a little neater. 2 plus the quantity 9 plus c. And they say, use the properties of addition to find the value of each variable. Okay, variable, no. C is a variable. They want us to come up with the number, the number that's associated with C here, the value for it. Now what we did last time, we saw that when variables can represent any one of a number of different values. Except here, we've got a pattern. 2 plus 9 plus 4. 2 plus 9 plus something. The parentheses are in different places. Do you recognize a pattern here? What if I put it in algebra for you? A plus quantity A plus B plus C is the same as A plus the quantity B plus C. Do you recognize the property here? The property that we have here is the associative property of addition. It says our grouping doesn't matter. So we've grouped the first two numbers together here. We've grouped the last two numbers together here. So what does that C have to be? Yeah, C is equal to 4. So that's what they're wanting you to look for. It's nothing mysterious or mystical or particularly difficult. As long as you understand, this is the associative property. If they're grouping the same stuff together, they just stuck a 4 in here where that C is. So let me look at page 8 now. And this says, what about if they ask you to write an equivalent expression for something? What's it mean when things are equivalent? Well, it means they have the same value. If you have 8 plus C, can you write something that has the same value of that? Using the commutative property? Well, what's a commutative property? Doesn't matter what order. 8 plus C, your answer would be C plus A. It's really important that you're able to do this because you're taking the English and demonstrating to me that you know what the English means. Now, what if they say write an equivalent expression for this using the associative property? You have 28 plus the quantity P plus 15. Here's my first expression. It says write an equivalent expression using the associative property. What's an equivalent expression? Something that has the same value. It means the same thing. What's the associative property? Well, the associative property tells us that the grouping doesn't matter. Here we group together the last two numbers. Let's group together the first two numbers, 28 plus P, that quantity, plus 15. That's all they're asking for. Okay, let's see what else. This says write an equivalent expression. What property are you using? How about y plus 0? What's an equivalent expression? Y. What property are you using? You're using the identity property. It says that if you add 0 to anything, you don't change its value. Okay? It's really all that we're talking about. Commutative property, the order in which you add two numbers together, doesn't change the value. The associative property, the order in which you group a series of numbers together that you're adding, doesn't change the value. Identity property, when you add 0 to anything, you don't change its value. That's the end of section 1.2, properties of addition.